Hello viewers, and welcome to another edition of Jackson's Journal. My name is Matthew Jackson, and today I want to talk about the Titan submersible that was made by OceanGate. And OceanGate is a company that does expeditions or tourism underwater. And they created a submersible called the Titan. And one of the things that made this submersible different than most other submarines or submersibles is the type of materials that they used. But before I get into that, please, if you haven't subscribed to my channel, please subscribe, like, share, and comment, of course. And if you would stay with me till the end, because if you watch this video to the end, the algorithms on YouTube will pick that up and then push it out to the feed and help even generate more views. So thank you for doing those things for me. I was in the quality field in my 35+ years in the workforce. I worked in the field of quality for 25 of those 35 years. And even before I went into the quality field, 8 years I worked as a bar saw technician for a metal company. And I learned a lot of quality control principles working for them. And then of course I worked for a fast food joint for a year and a half, and you pick up some quality principles there as well. So anyway, I had a lot of quality background in my profession. So now I want to give my take on this whole Titan submersible thing from a quality perspective. On June 18th, the submersible called the Titan was doing a voyage down to view the wreckage of the Titanic. And this submersible had 5 passengers. And the submersible, when it reached near the Titanic, now you got to remember the Titanic is 2.3 miles down below the surface of the ocean. Okay, that's a long way. Okay, so anyway, as it was going down, or as it reached the Titanic, the submersible imploded. And of course, the 5 people who were on board that submersible obviously perished, and it's history for those guys. So, very sad story. Now, one of the things I did as a quality professional, especially as a quality manager, because of the 25 years I was in the quality field, I worked 16 of those years as a quality manager. Then I worked 7 years as a quality consultant, and then 2 years as a quality assurance analyst. But one thing, when a non-conformance happens, one of the things you got to do as a quality professional is obviously you got to document the non-conformance. And the reason you want to document it and get it on record, but that way you'll have if you document all your non-conformances, you have a database of information on your non-conformances, and then you can look for trends and stuff like patterns and trends, and it helps improve your organization. But one of the things I had to do as a quality manager is I had to investigate the non-conformances and determine what the root cause of a non-conformance is. Sometimes it's a matter of routine. You know right away when you see the non-conformance report. You record it on the non-conformance report, either on paper or electronically, which that's how non-conformances are recorded today, is electronically in a computer system. But regardless of how you record it, obviously you want to get the facts, and it's almost like investigating a crime in a lot of ways, because you gotta get all the facts and be a detective, that sort of thing. See, you always ask yourself, well, what is the root cause? Sometimes you know what the root cause is right away. Other times you can't know the root cause. It's hard to find out, and there's only so many hours of investigation you can put into a nonconformance, because if you put too many hours, it's not cost effective. And then, so sometimes you don't know, sometimes you do know, sometimes it takes a while, a lot of investigation to find out. But at any rate, as for the Titan sub that imploded on June 18th, 2023, near the Titanic, the root cause is becoming more and more obvious as I listen to more news reports about that incident. And it was poor design validation. That was the root cause of this accident. And let me explain. Companies that manufacture product, and there has to be a degree of design and development going on before you manufacture it, obviously. And you have your design input, design output, design review, design verification. Those are all academic exercises. The design input is the input that you get from your customer who wants you to build the product for them, because they'll tell you what they want the product to do, and what the features and characteristics should be. You then take that data and render a drawing and some specifications on what their product should look like. You give it to them, they review it, you go back and forth, and finally you come to a design that both the customer and the manufacturer can produce and are willing to produce at the right price. Then design verification is when the engineers do their mathematical calculations and say, well, if we make it with this type of material, with this much pressure and force and blah, blah, blah. So the verification side is just doing mathematics and calculations. However, what makes design validation is a little different is you actually take the product and put it to use. You actually test the product. Now, of my 16 years as a quality manager, 12 of those years was with a crane company. And in that industry, when we made a crane, let's say we made a crane that had a capacity of 100 tons. Well, after we manufactured the crane, tested it at the factory, everything that we could test, obviously shipped it from the factory to the customer's site. It gets erected, gets commissioned, they make sure that the crane works at the customer's site. Part of the commissioning of the crane is actually testing the crane. So let's say the crane is rated for 100 tons. It'll lift 100 tons. Well, when you design, validate a crane, you test it with 125 tons. So you go 25% more than what the crane is rated for, okay? So what you do is you take a weight that's 125 tons, you lift it all the way up, lift it all the way down, lift it up again, run it up and down, use the trolley to run it up and down the bridge of the crane this way. And then you take the bridge of the crane, run it up and down the runway, okay? So you do that a couple of times, do the trolley a couple of times, lift it up a couple of times. And if it can handle 125 tons, then we have a high level of confidence that that crane's going to work very well for a 100-ton rating. Okay, so that's how design validation works in the crane industry. So design validation varies from what industry you're in and what kind of product you're producing. But I can tell you this, with this Titan submersible, there wasn't enough design validation. Now here are some red flags that give this away. First of all, the submersible was made out of carbon fiber and titanium. Okay? That right there is a red flag, because how many subs or submersibles, for that matter, are made out of carbon fiber and titanium? Very few, if any, hardly any. Okay? There have been dozens and dozens and dozens of voyages down to the Titanic, both in manned and unmanned subs and submersibles, with no problems, no implosions, no incidents. But obviously, we had an incident on this last one. And you got to ask yourself why. Well, the other subs were made out of materials that subs are normally made out of. And these subs and submersibles were, the design models to make them were conventional. The designers and developers did not break away from convention, okay? That's the difference. So no sub has ever been made out of carbon fiber and titanium before, okay? This is a new variable introduced into the mix. And any engineer will tell you that if you want to avoid problems, eliminate, narrow down as many variables as possible. You want the fewest amount of variables as possible. When OceanGate made this sub, they introduced more variables. That's what you don't want, okay? So that's the root cause. Now, I heard that this sub actually made 13 trips. This Titan submersible made 13 trips down to view the Titanic over a 2-year period. And so you think, well, gee, if it worked 13 times before, then why wouldn't it work on the 14th time? And maybe that's why those 5 guys got in that submersible to go look at the Titanic, because they figured, well, it's worked 13 times before. But obviously, that wasn't enough design validation for a submarine, especially being made with unconventional materials and using an unconventional design model. Obviously, the design validation had to be a little more extensive than just 13 trips over a 2-year period. Now, I went to OceanGate's website, just a little bit about OceanGate Inc. They are a private company that was founded in 2009. They have 47 employees, and their headquarters is in Everett, Washington. I looked at their website, and what's really odd is their website is still advertising tours to go see the Titanic. Can you believe that? After their submersible imploded, I think they need to let their webmaster know to take that down. Who is going to want to go see the Titanic with OceanGate? They had no backup plan when they went down there. Usually submarines or submersibles that go down and view the Titanic, usually they have 2 submersibles or submarines at a time. That way, if one submarine gets in a jam, the other can help them out. No backup plan on this mission. Now, one of the things I checked for on their website to see if OceanGate Inc. was ISO 9001 certified. I saw no indication that they were, and I don't know how compliant to 9001 they are either. You can be compliant to ISO 9001 without being actually certified to it, okay? If I was an auditor, the first thing I would be auditing is their design and development program, especially the validation part. I'd like to know how they conduct their validation activities. Interestingly enough, the 9001 standard prescribes, the ISO 9001 standards is an international standard for quality assurance program. It's basically a building code for quality management systems. But anyway, section 8.3.4 paragraph D of the 9001 standard prescribes that the organization must have a design validation program in their system. It reads, the organization shall apply controls to the design and development process to ensure that validation activities are conducted to ensure that the resulting products or services meet the requirements for the specified application or intended use. This did not happen because obviously 13 trips already was not enough trips to validate. Okay? Now, one thing about carbon fibers and titanium, it's very possible if that submersible was only used for shallow diving applications, let's say, 100 feet, 200 feet, something like that, less than a mile, less than a half mile, a quarter mile, something like that, something very shallow, it's very possible that those materials could have worked, titanium and carbon fiber, for a shallow diving application, and you could probably have done unlimited voyages. And if there were metal fatigue problems or just fatigue problems in the materials, you would see that, and you wouldn't be too far down, and you'd probably see a leak coming in, and it wouldn't implode right away. There's a difference between being 100 to 200 feet below sea level and being 2.3 miles. 2.3 miles, that's a lot of weight, a lot of water pressure on a sub at 2.3 miles. 100 feet, 200 feet, not that big of a deal, So the depth really would dictate that. But yeah, as a quality professional, in my opinion, OceanGate did not go far enough in their design validation. And that's why we have a sub that imploded on June 18, 2023. Anyway, that's my opinion from a quality perspective. For those of you engineers or quality professionals who, especially those of you guys who are in the marine ocean vessel industry, please feel free to comment and give me your perspective on the matter. Thank you for watching, and God bless.